Hey guys, this is Funday TV presenting you a session on probability distribution. So in this session, we are going to study about probability distribution. We are going to learn about variables, and random experiment. Then we'll take you through discrete and continuous random variables. So random variable is of two types, discrete and continuous. Then we'll take you through the core topic, that is probability distribution, and then we'll take you through the applications of probability distribution, that is mean, variance, and standard deviation. Okay, so just understand the flow. We'll first tell you why should you study probability distribution. Then we'll take you through the basics of probability distribution. Once we have discussed the basics, we'll take you through the topic in detail, and then we'll talk about the applications of this topic. Okay, then we'll talk about the applications of this topic. So we'll talk about why probability distribution, we'll take you through the basics, we'll take you through the detail of probability distribution, and then we'll talk about the applications. So first thing first, why should you study probability distribution? Okay, so consider a case wherein Rachel has an ice cream stand and she wants to analyze sales to expand her business. Okay, so she has an ice cream stand, she sells ice creams and she wants to expand her business. So she would definitely analyze her sales. Put yourself in her shoes. Imagine that you currently have an ice cream store and you want to increase the sale of ice creams. So for that you will analyze the sales. But then just wonder, where is probability distribution going to help you? So in the end of this session, we would understand that probability distribution is a very effective business business tool, right? To help you make sound business decisions. Okay, it will help you actually make sound business decisions. Okay, so considers that X is the number of ice creams that a customer orders. Okay, so when a new customer is coming into her store, he may he may buy one ice cream, he may buy two ice creams, he may buy three ice creams. Okay, so suppose that X is the number of ice creams that a customer orders. Okay, and suppose that X varies from 1 to 6. Okay, so a customer can buy 1, 2, 4, so on to 6 ice creams. Okay, and the number of customers buying one ice cream are 225. Likewise, the number of customers buying 4 are 20. Okay, now the question that she asks herself is, how likely is it that this next customer who comes to her store will buy just one ice cream? Another question that she asks herself is, out of 200 random customers, how many customers would buy more than 3 ice creams? More than 3 means how many customers would buy 4, 5 or 6 ice creams? Okay, so these are the questions that we would be answering at the end of this chapter. Okay, so let's go through the basics first. Let's understand what variables random experiment and random variable is. Okay, so essentially random variables are derived from random experiment. Okay, so what is a variable? Variable is a symbol that can take any value. Okay, so if I say that x is equal to 6 plus 10, or else x is equal to 16, then x is a variable. Okay, likewise, what is a random experiment? So consider an experiment that can have more than one possible outcome. Okay, so for example, consider the tossing of a coin. Okay, consider the tossing of a coin. Okay, so the outcome would either be head or a tail, right? So this experiment of tossing the coin will have one more than one possible outcome, and each outcome can be specified in advance, right? So before you toss the coin, you actually know what the possible results could be, right? And then the outcome of the experiment actually cannot be known until you conduct the experiment. Okay, so until you toss the coin, you don't exactly know whether it's going to be a head or a tail. Okay, and same goes for rolling a die. Say when you roll a die, you can get 1 2 3 4 5 or a 6. Okay, but then you don't exactly know what the outcome would be unless you conduct that experiment, unless you roll that die. But then each outcome can be specified in advance. You are sure about one thing, that the outcome is going to lie from 1 to 6. And again, this experiment can have more than one possible outcome. It can have one, it can have two, it can show up two, it can show up four, it can show up six, right? So what is a random variable? Okay, so a random variable is essentially a set of possible values from a random experiment. Okay, so in the case above, we saw that when you roll a die, you get 1 2 3 4 5 or 6. Okay, so a random variable, say x, is a set of possible values from this random experiment. So x is a random variable here. Okay, so now let's talk about discrete and continuous random variable. Okay, so we talked about random variable. It's actually a derivation from a random experiment. But then there are two types of random variables, which is actually important for you to understand, because you might be asked about the difference or the definition of discrete and continuous random variable. Okay, so let's talk about discrete random variables first. So if the possible outcomes of a random variable can be listed out using a finite set of numbers, then the random variable is discrete. Okay, so for example, when you roll a die, you know that the outcome is actually a finite set varying from 1 to 6, right? All integers. So this is a discrete random variables. And continuous random variables, so if the possible outcomes of a random variable can only be described using an interval or a range of real numbers, then the random variable is continuous. Okay, so for example, in case of a newborn, his or her weight can lie from 0.5 kg to 5 kg, and any value in that interval. Okay, so this is a continuous random variable. Okay, so consider the case study that we were talking about, selling of ice creams. Okay, so there the customer who comes in, he may buy one, two, four, or so on to six ice creams. Okay, so the number of ice creams bought by the customer is actually discrete. Okay, and consider the weight of the ice creams. Okay, consider the weight of the ice creams. Okay, so let's say that the weight of the ice cream varies from, say, 0.5 grams to 50 grams. Okay, so in that case, this is a continuous random variables. Okay, just one minute difference that I want you to see is, if you write the weight of the ice cream as 0.5 and 5 within curly brackets, okay, then this won't be right. Okay, then it means that the weight of the ice cream could either be 0.5 or 5. Okay, but if you write it like this or like this, then it means that the weight is a continuous variable. Okay, so then it means that the weight is a continuous variable. Okay, so so whenever you're talking about continuous variables, this is how you should write it. Okay, so that's about discrete and continuous variables. Now let's get into the main topic, that is probability distribution. Okay, so a probability distribution is essentially a table that links each outcome of an experiment, of a random experiment, with its probability of occurrence. Okay, so consider the number of ice creams bought by the customer. Okay, it could be 1, 2, 3, 4, 5 or 6. Okay, now the number of ice creams bought by the customer could be linked to the probability of the occurrence of this event. Okay, so the number of ice creams, if the number of ice creams bought by the customer is 1, so the probability of this occurrence is 0.45. Likewise, the probability that the customer buys 4 ice creams is 0.04. Okay, similarly, the probability that the customer buys 6 ice creams is 0.02. The question is, how likely is it that the next customer buys just 1 ice cream? Okay, so probability that the next customer buys just 1 ice cream, you see directly from here, that is 0.45. Okay, now out of 200 customers, how many customers would buy more than 3 ice creams? Okay, so how many customers would buy 4, 5 or 6 ice creams? So what is the cumulative probability of a customer buying? So what is actually the sum of the probabilities of the customer buying 4, 5 or 6 ice creams? That's 0.04 plus 0.04 plus 0.02, that is 0.10. Okay, so out of 200 customers, the probability that the customer is buying more than 3 ice creams, that's 4, 5 or 6 ice creams, would be 200 into 0.1, that's 20 ice creams, that is 20 customers. Okay, so now let's move on. Let's talk about the mean of a probability distribution. Okay, so if I ask you a question, what is the expected number of ice creams bought by a customer? Okay, so suppose that there is a random customer who walks into the store. So what is the expected number of ice creams bought by this particular customer? He may end up by 1 or 2 or 3 or 5 or 4 or 6 ice creams, right? So what is the expected number of ice creams bought by this customer? Okay, so expected number means the average or the mean. Okay, so to find out the mean, we use this formula, that is sigma xi into pi. Okay, so we essentially draw out the probability distribution table. So first, second and third columns of this table comprise the probability distribution table, and once the probability distribution table is drawn, we find out xi into pi. What is xi into pi? It's 1 into 0.45, 2 into 0.34, that is 0.06, 3 into 0.11, that's 0.03, similarly 4 into 0.04, that's 0.16, and then 0.02 and then 0.1. 2, right? And then we sum up all these values to get 1.94, and that is the expected number of ice creams bought by a customer. Okay, so if you see, this is actually a weighted average is what you can say. Okay, so the mean of a probability distribution is actually a weighted average. Okay, and to find it out, you just draw this probability distribution table, and then you multiply the probability with the value of the random variable, and you sum up all those values to get the mean. Likewise, what's the variance and standard deviation of a probability distribution? So variance, the essence of variance remains the same. Okay, so it's actually the measure of variability between the numbers in a data set. Okay, that is how far each number in the set is from the mean. Okay, so so talking about standard deviation, we all know it is square root of variance. But if I just want you to take you through the diagram just to make you understand it better, suppose that this is a distribution, okay, and this is the mean of the distribution. You take up a point here, okay, you take up a point here. So this is the standard deviation of this point, which tells you the variance of this point from the mean, like how far this number, say x1, is from the mean. Okay, so that's what a standard deviation or a variance means in a diagram. Okay, so let's move on. So the formula for variance, it's actually xi minus mu whole square into pi, and the simplified version of this formula is you just need to find out what xi square is multiplied by pi and then subtract mu square. Okay, and standard deviation is just the square root of variance, that is square root of sigma. Okay, so to find out, so we continue till this part, that is we continue to find out the mean from the first three columns, that are the columns which comprise a probability distribution table, and then we find out what xi square is, and then we multiply it with pi. So what is xi? Xi is this 1, so you square this and you multiply it by the probability, that is 0.45. Similarly, you square this x2 value and then you multiply it with the probability, that is 2 square into 0.34. Similarly, 3 square into 0.33, and then you sum up all these values. So you add up all these values and you get 5.16, and then you'll have to subtract the square of the mean, that is 5.16 minus 1.94 square, to arrive at the variance. So the variance here is 1.4, and then you take the square root of variance, that is 1.4, to arrive at the standard deviation. Okay, so let's look at the process again. We have the probability distribution table in place. We square each element of the random variable and we multiply it with the corresponding value for the probability, and then we sum up all those values. Okay, you may be wondering how you could derive these formulas, or do you actually need to remember these formulas? No, you won't actually need to remember these formulas. You can intuitively say how you can find out these formulas. Okay, so when you talk about any point xi and you want to find out the variability of that point from the mean, what would you do? you would say xi minus mu. Okay, so that's what the first term here means. Okay, and then you'll have to multiply it with the, then you square it, because variance is essentially square, and then you multiply it with pi. Why do you have to multiply it with pi? Because we are talking about weighted averages here, right? We are talking about weighted averages here, because xi has a probability pi, so we multiply it with the corresponding probability pi. Okay, so that's how you can actually intuitively think about this formula. And how would you arrive at this particular formula? Okay, so how would you arrive at this particular formula? Say xi square into pi, okay, minus mu square. So that can be arrived from the formula above. Okay, so so we can actually find it out. So what is xi minus mu whole square? That would be equal to sigma of xi square into pi plus mu square into sigma of pi, right, minus 2 into mu into xi into pi. Okay, what is xi into pi? Xi into pi is the mean, that is mu. So you can rewrite this expression as sigma xi square into pi plus mu square. What is sigma pi? Sigma pi is the sum of all the probabilities, so that would be 1 minus 2 mu square. So this is mu multiplied by mu will give you mu square, and then you sum this up, cancel out mu square, you get x sigma xi square into pi minus of mu square. So that's how you arrive at this particular formula. Okay, so so you just have to multiply, you just have to square the random variable, multiply it with the probability, sum it up, and subtract from the square of the mean to arrive at the variance. Take the variance, you arrive at the standard deviation. Okay, so in this topic we discussed about the variance, standard deviation, mean, probability distribution. We discussed about the applications of probability distribution, and now you know how you can answer the caselet. So about probability distribution. In the next session we would take more questions on probability distribution that might throw up in your exam. So till then, have a great time. Thank you so much, and thank you from Funday TV.